Hello everyone, this project is for Data 690. My name is William Chen under Professor John McKimbey. This project focuses on predicting diabetes using the machine learning technique. So the main goal of this project is to build a supervised machine learning models that predict whether someone has a diabetes based on the health and the lifestyle indicator. Up to Unit 5 or Assignment 5, I've completed several major tasks. So I identified the research problem and I explained why diabetes prediction is a meaningful topic. And I identified the critical success factor, a key performance indicator for this project, which helped guide the direction and the evaluation measure. I then reviewed the prepared behavior risk factor surveillance system, which is also called brief dataset. Explore the data with the descriptive statistic and then visualization, and test a few early models such as a logistic regression, random forest, and then gradient boosting. So those steps provide the foundation for improving the model and continue with the later units. So this project, I addressed the growth impact of diabetes on public health. Diabetes has become increasingly common and many people don't even realize they have it. When diabetes goes undiagnosed for too long, individuals face a much higher risk for serious health complications such as kidney failures, heart disease, nerve problems, and vision issues. For data science perspective, the challenge is to analyzing the health indicators, things like body mass indicators, blood pressure, cholesterol level, physical activity, age, and general health status. This is to determine whether we can predict a person's diabetes status with reasonable accuracy. And our goal of developing the model with a target of at least 85% of the accuracy, and of course, the higher percentage of the accuracy is better. The goal of my machine learning components is to create a supervised classification model that use this measurable factor to predict whether someone has a diabetes or not. Identify risk early is helpful because it gives people a chance to make a lifestyle change sooner, seek medical health earlier, and avoid more severe complication. It also helps the public health professional design better prevention program, which might also allocate the resource more effectively. So early prediction is helpful because it supports preventive care, improve the decision making for the health professional, and also can reduce the long-term medical costs. Um, so this problem is significant because diabetes continue to increase globally. According to the International Diabetes Federation, over 589 million adults currently live with diabetes. Um, this number is expected to reach 853 million by the year of the 2050, as you can see on the chart, which all the way to the right. And diabetes is responsible for millions of the deaths each year and is one of the leading contributors to heart disease, kidney failures, and other severe conditions. It also has a major economic impact. Global healthcare spending on diabetes now exceeds almost like $1 trillion annually, and the costs continue to rise. One of the biggest challenges is that nearly 43% of the people with diabetes remain undiagnosed. This means that almost half percent of the people that with the diabetes are not receiving proper treatment early enough. So machine learning can help address part of these kind of issues by identifying the hidden patterns in the health data. This insight can support earlier detection, help doctors make a more informed decision, and guide public health planning. By using the predictive model, we can assist in flagging individuals who might otherwise go unnoticed and help create a more proactive approach to the diabetes prevention. For this project, so as I mentioned previously, that we are using the behavior risk factor surveillance system dataset, or BRIEF. And this is from the CDC. The survey is conducted every year, and it's one of the largest public health data collection in the United States. I work with the version of the fiscal year of the 2015, was published on the Kaggle and by Alex Table. It contains information from more than 253,000 adults and including 22 with like health, demography, and the lifestyle variable. The target variable in this project is a binary indicator which is showing like whether a person has a diabetes or not. One of the advantage of this dataset is that all features are numeric. There are no missing values in the versions that I use, which make the preparation process much more easier because I don't need to handle like a missing data or categorize the data, which is large size and variety of the health indicator. This dataset is ideal for the building supervised machine learning model and give us a strong statistical powers. As you can see on the Appendix A tables I show on the right side, this is not all the variables that I'm going to use for the diabetes prediction. So to prepare the dataset, I first review the structure of the data and confirm that all variables are already numeric and that there were no missing values. Since the dataset was clean and fully numeric, it didn't require the heavy pre-processing. I then create a binary target variable by converting the original diabetes binary from the 3 category, which is like 0 for no diabetes, 1 for pre-diabetes, and 2 for diabetes, and then group it into the 2 category with a 0 for no diabetes, pre-diabetes, and the diabetes right categorized to 1. So we only have a binary 0 and 1. After that, I identify which features were continuous and then binaries and ordinals. In this project, I did not apply the standard scalars because the model I use in this stage, right, especially tree-based models like random forest, also the gradients boosting, which are no sensitive to feature scaling. And finally, I create a stratified 90% and 10% train test split. So the stratification was important because the dataset has a noticeable class imbalance. I want the same distribution of the diabetes and no diabetes case in both the training and the testing set. All right, let's look at the first visualization. So this visualization shows the distribution of the diabetes outcome in the dataset. So with only about like 15.8% of the respondents report having the diabetes or pre-diabetes, while about like 84.2% report no diabetes. So this shows a clear class imbalance. Imbalanced dataset are common in the medical classification because disease typically occur less often than the healthy outcome. Identifying this early is important because if we use the standard training approach and the model might predict the majority class too often. It could achieve the high accuracy simply by predicting no diabetes most of the time, but it could be failed, right, by detecting the people who actually have a diabetes. So recognizing this imbalance helps the guide decision more about the model evaluation and whether techniques like resembling or class weight are needed later, or we can. I think we already applied for the stratification, so which helps a lot. Um, the visualization, the second one shows the heat map. So this heat map illustrating the relationship among all numeric variables in the dataset. Each cells in the matrix represent the Pearson correlation coefficient between two features, with the values from -1 with the strong negative correlation to +1 with the strong positive correlation. So on the color side, right, the warm color, like the red one, indicate the positive correlation, while the cool colors, like the blue one, indicating the negative correlation. The heat map is symmetric along with the diagonals. So only the lower triangle is showing for clarity. So based on the heat map, right, it reveals that several meaningful association between diabetes status and the other health indicators. So if you look at the first column, the diabetes binaries variable shows its strong positive correlation with the high blood pressure at 0.27 and high cholesterol at 0.21, body mass index at 0.22, and general health at 0.3 and difficult work at 0.22. So this moderate a positive relationship suggests that individuals who report higher blood pressure, elevated cholesterol, which is higher than body mass index, poor self-grade health condition, or difficult working, are more likely to have the diabetes. So this result makes sense, right? Based on the public health studies, which often cite these like factors or indicators as a strong risk indicators. The heat map helps identify which variables that might be most useful for prediction and which one may not contribute as much. It also can confirm that the dataset reflect realistic relationship between the health indicator and the diabetes. So let's move to the next, the third visualization, which is the last one. So it shows features importance from the gradients boosting model. The gradients boosting perform well in the early testing, so I use it to understand which features has had the most influence on the prediction. The top predictor including general health, high blood pressure, and body mass index, and high cholesterol, and age, and even the difficult work and heart disease attack and also be one of the considered. So knowing which features contribute the most helps guide the next stage of the modeling. It also helps verify that the model is learning meaningful patterns instead of the noise. So later in the project, and I will be using the shock analysis to explore future contribution in more detail and improve the interpretability of the model. But based on the future importance and for the future in prediction, I might just pick like top 10 of the most important features to do the predictions. Um, Throughout the project, I learned several important lessons. So on the technical side, reviewing data type, distribution, and class imbalance helped guide pre-processing decision. The visualization helped me understand relationship in the dataset and that when obvious from looking at the raw values, which is the raw data. Using a stratified split improved the model performance and helped maintain the realistic class ratios. And future importance also helpful for identifying the most influence variable early in the project. So, which is I mentioned previously, then we are going to choose like top 10 as a future importance to do the prediction. So on the project management side, defining the research problem early made the rest of the work much easier and clear. And identifying the CSF and the KPI helped structure the project and gave me the measurable goal to work around. I also gained more experience in simplifying the technical result and then presenting them clearly, communicating finding in a way that no technical audience can understand is also the important skills. And this project helped me to improve in those areas. All right, so for the next step, moving to the next part of the project, I will continue beginning like turning and compare multiple classification models by comparing the different kind of models, right? Random forest and also the gradients boosting. The goal is to improving the performance beyond the initial balance and baseline model. And eventually I need to choose one of the models that I'm going to proceed. And I will also evaluating the metrics like accuracy, recall, advanced score, and ROC outs. And this metric give a more complete picture of how well the model is performing, especially in the presence of class imbalance. And as I also mentioned previously, then I'm going to add the shock analysis to better understanding how the model makes prediction and improve its interpretability. And one of the modeling and interpretability steps are complete. And I will refine the visualization and begin writing the final capstone report. This will also include in the final models, interpreting the result and then summarize the key finding and for the next presentation. All right, so these are the main reference and I use throughout the project. Please feel free to ask any question or share any feedbacks about my report. Thank you for listening.